In this problem, we're shown a spring and then the spring's height after being launched, and then we're told to find the maximum height that the spring reaches. So to begin with this problem, we have to understand this fundamental part, that the mechanical energy of A is ultimately equal to the mechanical energy at point B. So these should ultimately be the same. And now, using the complete equation, the mechanical energy of A is going to be half mv A2 plus mg h of A plus the spring constant, half kx squared. And now we equal this to the same thing, but for part B. So for B, we have half mb squared plus mghb, and then plus half, without the spring constant in this case, since there's no spring in this area of the problem. And then we already know that this is going to be 0, since the initial velocity is 0 in this case. And then we also know here that it will also be 0. And we remain with the spring constant in this case, half kx2. And then once again, we know that this is 0 because of the velocity. And then mghb, we're not sure if it's 0 yet, because over here it does get launched. And there is a velocity, but we don't know what that velocity is. And then plus 0 in this case, because there is no spring constant. And then we are left with half kx squared is equal to mghb. And this is the height. So if we work this out, since we only want the height of B, we can put that the height of B is equal to half of kx squared, the constant, over mg. And this will be the equation that we're going to work with. So now let me clear this up. So working with this equation of HB is equal to half of kx squared over mg, we can start plugging in values now. So we do know the half remains. We know the kinetic energy in this case is 10 to the third, and then we know that x, or the displacement in this case, is actually 7 times 10 to the negative 2 meters, and then this part is squared as well. And now all of this goes over, we know that the mass is 1, and to keep gravity more simple, we put 10. So now simplifying all of this, we go down here, and the height of B will come out to be half times 10 to the negative 2. And if we keep simplifying this, we're left with about 50 over 200. And this can be simplified to 1/4. So the maximum height that this box is going to reach is 0.25 meters.